Welcome children. Let me discuss some very important theorems from circles chapter which are based on angles subtended by an arc or chord at a point on the circle. Now before starting the discussion of the theorem, let me discuss what do we mean by angle subtended by an arc or chord at a point on the circle. Suppose here we have taken two circles with their centers marked like this. Now what is the meaning of this statement that the angle is subtended by an arc or chord at a point on the circle? Suppose on this circle we have taken 2 points. First is A and second is B. Suppose this is the center O. Now let me take any point on the circle, suppose here C. Now if I say the angle subtended by this arc AB. Now I am taking the arc AB and I am talking about the angle subtended by this arc at any point on the circle. It may be on the circle or inside the circle. Now what it means, if I join the end point of this arc A and B, the end points are A and B. If I join these end points A and B to the point where we have to find the angle, then like this, suppose I want to see the point C. So let me join this point to A and C, then we join it with B. So right now I have joined the end points of arc AB to the point C. So you can see that there is a formation of one angle, this. So I will say the arc AB subtends an angle ACB on the circle. So this is the meaning of angle subtended by an arc on the circle. Suppose I join the endpoint of this arc to the center. Suppose O. I have joined. Now this angle AOB. So AOB is the angle subtended by this arc at the point O. So how to find what angle is subtended by an arc? Take the endpoint of the arc and join them by the help of straight line to the point where we have to see the angle. Then whatever angle is formed, that is known as angle subtended by an arc at a point. Now let me talk about chord. Now what it means by chord? Suppose in place of arc we have a chord. Suppose we have taken a chord X, Y. Now again we are talking about what is the angle subtended by this chord XY. Suppose a point here I am taking as Z. Center is suppose again here O. Now I want to know what is the angle subtended by a chord XY at point Z. So same like the case of arc, what I will do, I will join the end point of this chord with the point Z like this. This joined and we have joined this. Now we are obtaining this angle Z. So this is the angle subtended by XY at point Z. Similarly, if I want to see at the center, so I will join these end points with the center like this. So this is the angle subtended by this chord at the center. The same way if you take any other point like here, so what to do? Just join these endpoints of the chord with that point, and whatever angle is made, that is the angle subtended by a particular chord on that point on the circle. So this way we can understand the concept of or meaning of angle subtended by an arc or chord. Now we are going to discuss very important theorem based on angle subtended by an arc or chord at a point on the circle. Now the first theorem is angle subtended by arcs and chord at points on the circle. The theorem is the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. Now this is a very important theorem. What it says, the angle subtended by an arc of a circle at the center. कोई भी arc center पे जो angle बना रही है, suppose we can see here three figure, we have taken 2 point A, B on these three circles, and this is the arc AB. This is the arc AB. We are talking about arc AB. Now angle subtended by this arc at the center. So as we have discussed, these are the endpoints. So we will join these endpoints to the center. So while joining AO and OB, we have obtained angle AOB. So this is the angle AOB subtended by arc at the center. Now what it says, now this angle is double. Double means 2 times of what? The angle subtended by it at any point on the remaining part of the circle. Now if same arc subtend any angle on the remaining part of the circle, circle means this one. So on this, if it subtend any angle, suppose we have taken a point C here and we joined AC and BC. So now we have obtained angle ACB. Now this angle ACB is the angle subtended by this arc at any point on the remaining part of circle. So AOB is the angle subtended by AB at the center. ACB is the angle subtended by arc at the remaining part of the circle. Now theorem says that this angle at the center will be double of this angle on the remaining part of circle. It will be double means 2 times. So it means angle AOB will be twice of angle ACB. Now this is the theorem. Now we have to prove this theorem, that this central angle is double of this angle. Okay, now this is the theorem. Now same figure can be discussed in 3 parameters, like here the angle at the center is acute, here the angle at the center is of 180 degree means straight line, and here angle at the center is of is greater than 180, that means reflex angle. Here it was a minor arc, so minor arc was subtending an acute angle at the center. Here it was semicircle, so it was subtending a straight angle at the center. And here AB is the major arc. So major arc is subtended reflex angle at the center. So we have to prove that the angle at the center is double the angle on the remaining part of the circle. This is the theorem and we have to prove it. So let me go for the proof. Now, in this question it is given that we have a circle with center O. We are taking only one case and the proof will be same for all the figures. We have taken a circle with center O and we have taken here arc AP, means we have taken 2 points A and B, and the arc obtained by it is arc AB, this one. From here to like this rotation we can see, this is the arc AB. Now this arc AB is subtending at the center. So for that we have joined A to O, B to O. Now we got this angle at the center. Now we have taken a point C on the circle and we have joined this point with the end point of the arc AB, that is AC and BC. So we got this angle on the remaining part of circle. Now we have to prove that angle AOB is twice, means 2 times angle ACB. So this we have to prove. Now for this we have done some construction. We have joined OA, OB and produced CO. CO we have produced to the point D. Okay, so this is our construction. OA, OB joined, and from C we have drawn a line passing from O up to the point D. Now let me prove the theorem. And proof will be same for all the 3 cases, whether it is for minor arc, semicircle or major arc. Now let me focus on triangle AOC. If you will see triangle AOC, in this OA and OC will be equal. OC and OA will be equal because they are denoting the radius of the circle. The radius of the circle. So you can see that in triangle OAC, any 2 sides are equal. And we know that if in a triangle 2 sides are equal, then their opposite angles are equal. That is isosceles triangle property. So here angle 1 will be equals to angle 2. So angle 1 equals to angle 2. Now, so angle AOD. Okay, angle 1 equals to angle 2 we have obtained. Now one thing is this. Now we are going to use the exterior angle property here. Now which way? See, I have separated the figure like this. This is C this is A, and this is O, and this line is produced up to point D. Now we know the exterior angle property. If we see for triangle AOC, if we are looking at the triangle AOC, this is the exterior angle. This is the exterior angle which is denoted by A here. Now, for this exterior angle, we will leave this angle. So remaining two angles means angle A and angle C are the interior opposite angles. That is angle 2 and angle 1. So for exterior angle A, 2 and 1 are interior opposite angles. And we know that by exterior angle property, this exterior angle is equal to the sum of interior opposite angles. So we can write this AOD. Angle AOD equals to angle 1 plus angle 2. So this result we have obtained angle AOD equals to angle 1 plus 2, exterior angle property. Now in place of angle 2 we can write angle 1. So angle AOD will be angle 1 means twice of angle 1. Now here AOD. AOD we have denoted by A. So in place of AOD we can write A, that is twice of angle 1. Similarly we can see suppose this we have taken we can take 3. Suppose we take triangle OBC. In triangle OBC again OB and OC are equal. So this angle C angle B will be equal because isosceles triangle. So we have denoted them by 3 and 3. Now angle B is exterior angle again. So it will be equal to the sum of interior opposite, that is 3 plus 3. So angle B can be written as twice of angle 3 based on the similar pattern which we have discussed in the first case. Now we obtained A equals to twice of angle 1, B equals to twice of angle 3. We are going to add both. So A plus B will come and here 2 will be taken common. So we will get twice of angle 1 plus angle 3. Now in place of A plus B, we can write AOB. So we have written angle AOB. And in place of 1 plus 3, we have written angle ACB. So we got angle AOB is twice of angle ACB. So this is the proof. This is very important theorem because angle at the center subtended by any arc or chord is double the angle on the remaining part of circle. So this is the proof. Now using this concept we can prove other questions also or other theorems also. Now a very important theorem which is directly used in the questions, prove that angle in a semicircle is a right angle. So we have to show that angle in a semicircle is a right angle of 90 degrees. Suppose we have taken a circle and this is the center O of the circle. Now we have drawn a diameter AB. Now we know that semicircle means half of circle. This is half of circle. So you can see that this arc AB, upper one, this arc AB is denoting a semicircle. Now on this semicircle, if we take any point, suppose we have taken C and we have joined this with A and B like AC and BC. So we are getting one angle here. Now because this angle is made by this semicircle, this AB is the diameter of the circle. So half part, this is semicircle. So this angle C is made on a semicircle. So theorem is saying that this angle should be of 90 degree. So let me prove it. Here we are going to take the help of the theorem that angle at the center is double the angle on the remaining part of circle. We will join AB. Now for arc AB downwards, if we see downward arc AB, now this arc is subtending this angle AOB at the center. How we got it? We joined this A to O, B to O. So AOB, this angle. This is the angle subtended by this arc AB at the center. Similarly, this arc AB is subtending angle ACB, on the remaining part of circle. So this is central angle, this is the angle on the remaining part of circle. And we know that the angle at the center is double of this angle. So we can write angle AOB is twice of angle ACB. This we have written. Angle AOB is twice of angle ACB. Now we can easily see this angle AOB is of 180 degree because straight line. So we can write in place of angle AOP 180 degree. So we obtain twice of angle ACB equal to 180 degree. If this 2 will go in the down, so angle ACB will be 90 degree. So this angle will be of 90 degree. So this we have obtained that if we have any angle in the semicircle of the circle, then it will be of 90 degree, like this. Suppose we have taken this and we have taken this and we have drawn a diameter and we have taken this one angle. So this angle will be of 90 degree. So this is a very important theorem. Now moving on to one more theorem based on the same concept, that angle at the center is double the angle on the remaining part of circle. And the theorem has proved that angles in the same segment of a circle are equal. Now angles in the same segment of circle means, suppose this is a circle. Now we have taken 2 points, A here and B here. Now for this arc AB, on the opposite side of, means in front of AB, this portion. In this portion, if I take any point, suppose I have taken a point here C, here I have taken a point D, and here I have taken a point E. So these points are in the same segment of AB. On the same side of AB they are coming, so they are in the same segment of AB. And if I join them with the AB, suppose this, so I will say this is the angle subtended by AB at C, this is the angle subtended by AB at D, and this is the angle subtended by AB at E. These are the angles subtended by arc AB, and these are on the same side of AB, opposite side, so they will be known as angle in the same segment. Now this theorem is saying that angle in the same segment are equal, means this arc is subtending CDE on the same side of it, that is angle in the same segment. According to the theorem, these three angles should be equal. Now we have taken a figure here, we are taking an arc AB for all the three cases, and this arc AB is subtending angle C, angle D on the same segment, means this one angle and this one angle, these are angle on the same segment. Now we have to prove that these angles are equal. So it is very simple to prove. What we will do, we will join this arc AB to the center O. So we will obtain OA and OC. Now this arc AB is subtending this angle at the center. Now we know that angle at the center is double the angles on the remaining part of circle. So for this AB arc, angle AOB will be twice of angle C. Similarly, angle AOB will be twice of angle D. Now this we can see here. This angle AOB is twice of angle ACB, because this is the angle at the center by the arc AB, and this is the angle on the remaining part of the circle by the same arc. So this angle AOB will be double of ACB. Similarly, angle AOB will be double of this angle D, same theorem. So we have written here. Now in these two results we are watching that this angle AOB is same. So we can write twice of angle ACB equals to twice of angle ADB, we have written here. Now 2 and 2 cancelled, so we got ACB equal to ADB, means this angle equals to this angle. So this way we have proved that angle in the same segment are equal. And same way we can prove for remaining two cases. It's very important to understand angle in the same segment means if we are taking any 2 points on the circle, then on the same side of circle, suppose I am taking the upper side, so these are the angles in the same segment which I am making here like this. So as per the theorem, they will be equal in measure.